Hello everyone, welcome to the course on artificial intelligence in industrial and management engineering. Till now in the course we have covered various topics like basics of machine learning, and in the last lecture we have delved into what are the neural networks, what are the foundational concepts of neural networks, and then we introduced various terminologies like what is deep learning, what are different kinds of layers that are developed while training these kinds of algorithms. So, today we will directly go to our development environment and we will try to extend our diamonds dataset example, so that we can understand how to get finer details and better solutions by training our neural network algorithms from the scratch, right. Okay. So, let us start our Jupyter Lab environment. So, we have already started this environment in our machines. Till now we have covered various things in diamond dataset, like we have first imported our libraries here. Okay. So, we have imported Seaborn, Matplotlib, Pandas and NumPy. Also then this is just a basic revision of what we have done till now in this diamonds dataset. So, we initiated our analysis by reading the data from the CSV file. Then we created some functions for developing various kinds of visualizations that we require in this analysis. So, this is for the bar chart, then this is for the box plot, and afterwards we started creating our analysis for different kinds of variables that are included in this data set, right. Now, like we have done our analysis on clarity, categorical data, or color, variation of price, right. So, this way we have done basic exploratory data analysis of this data set. Afterwards, we started creating our split for conducting our machine learning analysis, right, and we utilized linear regression model from scikit-learn library, and we also did evaluation of the model by first developing it, and then we utilized like mean absolute error, mean squared error, or R2 square, R square score from the sklearn.matrix library. Okay. So, finally, after conducting our linear regression model from scikit-learn library, we developed a model that has these kinds of metrics, like the mean absolute error is $879 and the R square score was 0.85. Now, we can improve these scores by conducting different advanced algorithms like SVM or random forest algorithms, but since we have already introduced you to the neural networks concept, we will try to implement the neural networks by developing neural networks on this dataset, so that we can understand whether we can improve our accuracy by creating this model using these kinds of algorithms. So, to do this, let us first create our index for telling the users that we are now developing a neural network model. Okay. So, to utilize neural network libraries, we will first need to import it. So, we will import from scikit-learn .model .neural network. Import MLP regressor. So, we have introduced you to multi-layer perceptron, right. So, this is the multi-layer perceptron regressor for regression task. Now, the next thing we need to include is from sklearn.pipeline import two functions, make pipeline and pipeline. Last is from sklearn dot preprocessing. So, this standard scalar is a feature processing function that will try to scale all your data inputs by utilizing the normalization concepts. Okay. So, we will conduct this study into 3 steps. So, let us first mark that this is our first attempt of getting better at our linear regression problem. Okay. So, let us first try to print what is the input of variables and label variables. So, we can see x dot extreme extreme. So, this is the shape of our numpy variables, numpy arrays, which contains the training data for x and y, right. Now, let us try to initialize our regression model utilizing the neural networks. So, we will use this function and we will first address the number of layers in our neural network. So, this will be hidden layer sizes and it will be a list. So, today we are trying to develop a neural network model with 3 internal layers and each layer has 500, 250 and 100 neurons. So, now you can understand that while we were discussing about different kinds of layers and the number of neurons in those layers, these are actually utilized in this scikit-learn library like this by utilizing this function and specifying the number of neurons directly. So, all those finer details gets addressed behind the scikit-learn library's implementation. Now, you also need to specify the random state, means the random number generation list. So, we will now also utilize this make pipeline function and I will address why we are using this. So, the first line, this states that you have specified your neural network with 500, 250 and 100 neurons in each layer. Next thing is you need to process your input data and your training labels through this pipeline. The pipelines here mean is that your input data will go through this standard scaler process and it will scale all the input variables utilizing this function. After that, whatever the output of this function, it will be the input for this MLP reg object and MLP reg is defined here, which is nothing but your neural network. So, the input to your neural network will be scaled input data set, right. Finally, to run this whole model on your input data, you need to use the fit function from scikit-learn library. So, this is how you will train your models by utilizing the different kinds of functions from scikit-learn library. Okay. Now, this star and this filled circle shows that the machine is still running the function and it will give an output soon. So, once all these operations finish, you will get something like this. This is your pipeline and these are your parameters. The first operation was standard scaler and the second operation was this MLP regressor, and it mentions that your hidden layer size is like that. Your activation function was ReLU. So, these are the different kinds of activation functions, but we have already talked about sigmoid functions and basic step functions in your previous lecture. So, these are some different kinds of activation functions. Then the solver used by this MLP regressor was Adam. You can tweak these settings for getting better results, right. So, these are all the hyperparameters that can be tweaked. Now, let us run our model evaluation here. so that we can understand whether we have gained something by implementing neural networks or we have lost something. So, to do that, we need to get predictions from this model, and that can be done by utilizing the pipeline object that we used to train this model and use the predict function from that. The input for this predict will be your X text, the test data set. Okay. Now we can calculate the model evaluation matrix. So, to do that, these things remains the same like in the previous simple linear regression model. We can use mean absolute error with your y underscore test and y underscore red. And the next thing is mean squared error. This is so first we will utilize mean absolute error, then mean squared error, then R square score. Okay, and all the input for all of these functions remains the same. Why? Because we are trying to get our evaluation matrix on your test data set and your predicted data set of labels, that is y values, right. So, that is why the first values is y test, second is y pred. Now, we have calculated all these. So, we can utilize our previous print statements like here. So, we can just copy and paste these things to save. So, now let us compare with our simple linear regression model what happened from there. So, initially the mean absolute error was $879 and R square was 0.85. In this attempt, we reduced our R square, which is not good, and the mean absolute error however decreased. So, in our next attempt we will try to increase this score as well. Okay. So, first now let us start with our second attempt. So, the distinctive feature of our second attempt would be that we will try to include one more derived variable in our data set instead of using all the included variables. So, first of all, let me show you what is your actual x values, what was your data frame. So, df dot info. Okay. So, you have had these variables like caret, cut, color in your data frame, and these x, y, z was 3 different dimensions of the diamonds. Now, we can multiply these 3 dimensions and get the volume of the diamond, which will include all the informations from these 3 features, and we can then remove these 3 independent features. So, this is what we are doing here. We have created a volume column, and in that we have computed the volume of each row. That means, for each diamond we have computed the volume, and we have stored this in our X array. Okay. Now, we can show this X data frame, and it still includes X, Y, Z, but it also has volume variable. Okay. Now, you can drop So, if you check again your X and N data frame, it will not have your X, Y, Z columns. Okay. Now, you have only 4 columns: caret, depth, table, and volume, and these all are numerical variables because the data type that Panda is showing is float 64. Now, we have our input data set. We need to again divide this data set into test and train, right. So, to do that, we can write X N N train, Y N N train, comma X test. So, we are again using this train test split function from scikit-learn, and we are giving 2 main inputs, the X N N data frame and the labels associated with all these rows. The test size here is 0.3, that means we are conducting a 70-30 test split, and the random state we specified is with 108. Now, we have all these 3 variables and our train test split. Now, we can write our neural network code again. So, let us directly use it. And here we will give X N N underscore train and Y N N train, because this is our second attempt, and these are the variables that contains the volume information. Okay. Okay, so here is a problem that we need to write X N N test and so we have trained our model for our second attempt. You may have seen that it happens instantly, but actually we removed the lag while we were waiting to train that model. So, these kind of waiting times depend on your machine's capability. So, if you have a very strong machine with high configuration, then these kinds of modeling will take less time. But since we are utilizing here like these only 3 layers, let us say you include 30 layers with much higher number of neurons in each layer, then your training times will increase exponentially. Okay. So, this is where the neural networks will require high end and state of the art infrastructure to get trained, right. So, now let us try to see how good or bad our model got trained. So, we can utilize these commands again, but instead of only ypred we can write this is for second attempt. So, ypred nn, and it works for x nn test. Why? Because our data set now contains x nn test, y nn test, right. So, this will give the predictions by utilizing this model. Now, let us conduct our model evaluation. So, we need to again change our variables ynn test and ypred nn everywhere. Now, you can see that our R square values increased to 0.88 and your mean absolute error is 786 only, $786. So, in your earlier attempt you got 0.82 as your R square, and in your actual attempt by simple linear regression model you had 0.85 as your R square. So, from 0.85 you have increased 0.88 by doing what? By reducing your data frame to only 4 variables that includes only numerical content, and you have dropped these 3 individual variables that provides information regarding your diamond's dimension, right. So, this is the second step of trying to improve your model. We will also have a third step. So, now let us continue with a third attempt. Now, what is the distinguishing feature of this third attempt is that we will try to include one categorical feature as well. So, to analyze your categorical feature, you need some other functions from the scikit-learn library, so that they can be transformed into numerical features and then get feeded into your machine learning algorithms or your neural network implementations, right. So, to do that we will include few more functions from the scikit-learn library. So, let us try to include that from sklearn dot compose import column transformer. So, we have written something wrong here. Next is from sklearn dot pre-processing import one hot encoder and standard scalar. Now, for the third attempt we will again create new variables x n n new, and we will directly utilize the original data frame and drop few variables that we do not require for this attempt. So, we will drop cut column, color and price. price is a label, so we do not require this in our X data frame. Y and in new will include only price from the actual data frame. Now let us try to look how our new X data frame looks like. So we can do this by utilizing the info function from pandas library, and we have XYZ column, caret, clarity, depth and table. Out of this only clarity is a object data type, that means it is a categorical data type, right. Now we can again develop the volume variable, because we now know that our second attempt improved something in our actual final metrics, right. So to do that we will again create the volume variable. So now we have our volume variable. Again we can drop these three variables. Now let us again create our train test split, so that we can segregate our data into training and test data set. So we can utilize the same code with newer variables, and we can write here as x and n new and y and n new. Rest everything remains the same. So we will utilize the same variables like xn and train, xn and test for our model building. Now we have, since we have two kinds of data set, that is numerical and categorical, so we can create two lists here. So we can write numerical features, and this is a list of caret, depth, table and volume. Our categorical features are like clarity. So we are not utilizing multiple categorical features right now, because we are just in our third attempt we are just including only one categorical, see whether it will provide anything better to our model building. Okay. So finally we will write our column transformer. So here we are creating a new variable preprocessor that will be an object, and what it will do is it will try to utilize these input data set from your training data set, and it will do all the preprocessing in these lines of code. How? It will first utilize the column transformer, which will take all the columns one by one, and if it is a numerical feature column, then it will use standard scalar. If it is a categorical feature column, then it will use a one hot encoder. So what is one hot encoder? It is nothing but, let's say you have binary data in your categorical data set, clarity, yes or no. So if it has only two categorical instances, that is binary, then it will create two different columns for this categorical feature with 1 and 0. Wherever the first binary value is true, then it will create 1 for that value. So this is how it will transform the categorical features into numerical features. Okay. So this is how you create your pre-processing pipelines in scikit-learn, right? You can also check how your preprocessor variable looks like. So it has two different items, num and cat, and for all the numerical variables it will utilize standard scalar, for others it will utilize one hot encoder, right? Now let us try to create our neural network implementation. And we will again use multi-layer perceptron regressor. So first we need to assign hidden layer sizes, which will remain same. And then we will assign a random state. Now to fit this model on your earlier pipeline, you will utilize the pipeline function that we imported earlier, and you need to first define your steps. So your first step is pre-processing. So create a new tuple and create this as a string first so that it is identifiable, and then utilize your object. Second step is your regressor. Which you just created inside MLP underscore reg object. Right, now you have created your pipeline. You can also store this pipeline in a new variable. So we can write pipeline new equals to this. Okay, now we came to the last part where we will try to fit this pipeline on our input data, right? So our input data is stored under x, n and train, and labels are stored under y, n and train. So now it will take some time because we are doing multiple operations and our neural network is also bit of large in terms of number of neurons. So let's wait some time. Okay, so now you have trained your model, and this is the third attempt where we included one new categorical feature, right? So now let us try again to get our evaluation matrices. So we can use the same commands for our new variables. However, our pipeline is now pipeline new, and x and y remains the same. After that, okay. So now you can see here that your mean absolute error has changed to only $536, which is a huge improvement in your model, in your final third attempt model. And the R square value is only R square value has improved to 0.93. So in your second attempt it was only 0.88, and in your first attempt it was 0.82, right. So this way, what this model is suggesting is that if you include a categorical feature like clarity to predict the values, the price of your diamonds, then it may be a better criteria and it will improve your final model for these kinds of predictions. Now in your next iterations, what you can do is you can include more categorical features so that you can understand whether including another feature will be helpful or not, right. So this is how your what we have discussed earlier, like your end-to-end machine learning process. This is an iterative process and you will need to come back and forth again and again, right. Also these kinds of things like matrix evaluation, we were writing here again and again, which you can create your own function, your utility functions somewhere, and then you can directly import these kinds of functions in your different machine learning projects. So we will stop here today and we will try to initiate new machine learning topics in our next lectures. Till then, you can try more feature evaluations and feature processing in this project, and you can ask your questions with TAs in the course. Thank you.